Today we're going to be talking about the pressure flow mechanism. The mechanism by which sap, a sugary water solution, moves around in the plant. And sap can literally move any direction. It can move up, it can move down, it can move sideways. And we're going to talk about how that actually happens. Now I've left up the xylem tube from the last movie. And we can see here the main way water moves up in the xylem is through transpiration. So I left that up here because in part the pressure flow mechanism depends on transpiration. So let's go ahead and write the pressure flow mechanism. That's what we're going to be talking about. So pressure flow mechanism. And this is the means, this is the way in which sap is going to move around. So over here, I'm going to go ahead and I'm going to draw a phloem tube. And phloem is going to be a little bit narrower on average than xylem. Let's go ahead and label that. That's going to be our phloem. And at the top of this phloem tube, I'm going to go ahead and I'm going to draw a leaf. And that's going to be our leaf. And let's go ahead and label that leaf. And the leaf is going to be our source. It's going to be a source of sugar, in this case glucose. The leaf is going to produce lots of glucose through the process of photosynthesis. And that sugar that's created in there, I'm going to go ahead and draw the sugar in red. That sugar that is created in here gets transported, actively transported into the phloem. So sugar, and let's go ahead and put that it's actively transported. So this does require some ATP on the part of the plant. The sugar gets actively transported into the phloem. So what we end up with here is a lot of sugar molecules. And this sugar is mainly in the form of sucrose. Although it gets produced as glucose, it gets changed later on into sucrose, and then that sucrose, that sugar, gets transported into the phloem tube actively. Now, because we have a lot of solute here, these sugars represent a lot of solute, it's going to attract water. Remember, water wants to move from where there's low solute to where there's high solute. So what's going to happen here is we have a xylem tube right next to this phloem tube. And some of this water is going to get diverted over to the phloem tube. And this is going to happen via osmosis. And then the pressure, the hydrostatic pressure, is going to increase here. And the plant can actually take this high pressure and use it to push this sap upward. If we're trying to move it to a fruit, maybe we're trying to sweeten up a fruit for later on. Or maybe we want to move this sugar downward and store it in a root. Because oftentimes roots are used to store sugar for the long term, especially with the approach of winter. So let's go ahead, we'll draw our root down here. And this could be a root or a fruit. So this could be a branch that's lower on the tree than this leaf, or it could be a root. I'm going to have this sap move downward, but it could just as easily move upward. Now the root or fruit is going to be called a sink. And a sink is where something ends up. In this case, it's going to be where the sugar ends up. So what's going to happen is that this sugar, this sugar water solution, this sap, is going to be squeezed or forced down here because there's a high hydrostatic pressure here. Now once we get down to the root, we're going to take that sugar and we're going to actively transport it into the root. Again, active transport. and the water cannot get into the root here. So what's going to happen here is the water is left behind, and the water is going to look for solute. It needs some place to go. So we're looking for a high solute concentration. There's going to be a low solute concentration here because we're taking this sugar from here and putting it into here. So that creates a low solute concentration here. And because of that, the water is going to look for some place where there's a higher solute concentration. And the xylem tube happens to have a slightly higher solute concentration because there are some dissolved minerals in the water as it comes upward through the root. And again, this water is going to move here via osmosis. And then as the water moves up through the xylem tube via transpiration and root pressure, so again, some of that water is diverted over here to equalize the concentration. And again, we're creating a high hydrostatic pressure here, and that pressure can be used to squeeze that water upwards, downwards, sideways, wherever it is needed. And that is going to be it for the pressure flow mechanism.